My name is Joseph Wunderlich. I'm a professor of engineering, architecture, and computer science. I spent a little over 2 years at IBM working on something related to what would become Watson, and Watson was in the 2010s. Later on, I worked in the mid-1990s at IBM, and then to date, 2025-26, Watson X. I was born in 1961. I'm 64 years old, recording this in 2025. I've been teaching for a long time now. I did a little over 2 years at IBM in research on large-scale multiprocessor systems, up to 512 processors, $1 million machines, and then I had high-tech bachelor's and master's degree, developed a couple neural network chips, did some robotics research, and in the 1980s, I built high-tech office parks and small data centers in Texas and California, and have a background in that field for undergraduate. This is details of my work at IBM. I was advisory level, which is one level below senior technical rank. There's a management track and a technical track, and so I was one notch below the topmost rank in research. And you can see here how what I worked on related somewhat to what would become the hardware that Watson would run on a decade later. This lecture will take an hour. When delivered live, this will be much shorter than that, because I'm just going to fly through these slides as an overview to make a recorded version. But from the beginning of the 2010s until 2025 and now 2026, Watson and now Watson X has been doing significant things in artificial intelligence.
But anyway, this is details on IBM Watson, and you can look at that, and I'm not going to go over that now. This is an overview lecture and how Watson works, and started playing just as a game playing application-specific use of AI and hardware and software, and then what they learned as they were doing that, IBM learned, and how that particular machine works, and the training, the tuning of it. And you can see, based on using previous data from other champions of Jeopardy, and it learns, teaching itself, more and more confidence in itself. It's a probabilistic guess based on certain things. It has neural networks in there too, and symbolic AI kind of things. And then problems. So I read a number of books about this, and then you can look at how I've summarized those. And so, where are we going with this? Take a look at that. More on Watson. More on Watson. More on Watson. And even more on Watson. Still going. So, this, come back, take a look at it. This is several lectures to cover this right. And much reading. Again, I forget how many different books I read about this, and I was inside IBM, and I've been working on machine intelligence for 30 years.
So finally here, finishing up with what's going on right now in 2025, the end of 2025, AI within IBM. And Watson still, but versions of new and improved Watson, and most importantly, on these high quality, secure systems. And I could tell you firsthand from being inside IBM that the quality control of everything going out the door is top notch. And so Watson now is Watson X, running on the systems that the new versions of the systems I worked on, the System 390s, which are now Z systems, and you can see some details of that. And importantly, on-chip AI accelerators in the hardware, so super fast and secure. So IBM, when I was there, was 450,000 people, 9,000 PhDs. I haven't seen anything else in industry like that. Certainly some high quality companies, but IBM was and still is a leader in technology, and AI is at the top. Um, and agency AI now, so reasoning, agency, and then to come will be in the robots, of course. So just to summarize and end this lecture, IBM now strategy of embedding AI into core enterprise workflows and infrastructure to drive productivity and efficiency in a secure, governed manner. And so, multi-million dollar machines, even back, there were $1 million machines when I worked on them in the 1990s, 512 processors, optical interconnects for 64-bit processing, lots of things inside of IBM participated in. And this is now 30 years later, almost, and yeah, IBM is still leading the way. You don't hear about them much. They're behind the scenes running the high quality machines that run the infrastructure of everything. And I believe, in my opinion, I think many people would agree that the quality of what these machines are doing, the data, and how the quality is guaranteed or at least vetted to some degree, if you're going to be doing critical things with the outputs of these systems, you want a big, reliable company doing it. And I think most people would agree with that. So on all these last couple pages was a Google Gemini search. You click on that and you can see where Gemini and how Google is actually with Broadcom creating its own processors to compete with NVIDIA and getting some market share there at this moment. So we'll see how that pans out. I believe Meta is going to jump in and use some of their chips too. But NVIDIA still leads the way. And so there's lots I can talk about in other lectures. You'll see about that and all the different processors and the trade restrictions and the bottleneck of how Taiwan is involved, where everything goes through there, and the politics that can affect that. And so that's for another time and place. But we'll end here on a high note. We've got IBM and its high quality controls involved in putting out some of the best AI.